Okay, we're back. We are today looking at how we can convert coordinates from rectangular to polar and polar to rectangular. So you have just come from possibly the introduction to this, or maybe you've already seen this before and you want to look at this again. So it all comes down to having these conversion equations and knowing how to use them. So if I wish to convert a rectangular coordinate x comma y into the polar coordinate system r comma theta, we have two conversion equations to use. One that gives us the radius and one that gives us the theta value. So if I have x and a y, I can x squared plus y squared, and it will equal the radius squared. So this should look familiar. It's the circle equation. If I square x, square y, I would just have to square root that value to get the radius. And then if I'm finding theta, I could say, well, y divided by x is going to equal tangent of theta, which I'm going to add here below that, because that's, y divided by x, that's not theta. So we would actually have to say, oh, well, then our tangent of y over x will equal our theta value. Okay, so two equations converting from rectangular to polar. How do we convert from polar to rectangular? Well, these are actually much simpler in the sense of they're much straightforward. So now I have a radius and I have my theta. How can I convert that coordinate into the rectangular system? Remember, guys, these coordinates represent the same location, it's just they're in different systems. So if I want to go from polar to rectangular, r, the radius, times cosine of theta, that should look familiar. This will give us the x value. And then for the y value, you probably can, you're already saying it, it's r times sine of theta. That's our y value. Much more straightforward. You take the r, the radius, multiply the cosine of theta, r, the radius multiplied by sine of theta, and you have your x and your y. So let's try this out. So let's say we have the coordinates, we're going to start with rectangular coordinates. Let's say we have the coordinate p, -1, 1. Okay, so it's important to note here where we are located. So we are located in quadrant 2. Make a little note of that. You'll see why that's important in here in a little bit. So we have our x and y. Okay, let's get the radius using our conversions. So to get our radius, we have x squared plus y squared equals our radius squared. And then let's say -1 squared plus 1 squared equals our radius squared. So that's 2 equals our radius squared. So our radius must be positive negative the square root of 2. All right. And then our theta value. So our theta will be the arctangent of y divided by x. Okay, so knowing our unit circle, we know that arctangent of really -1, that's what this comes out to. Arctangent of -1 is exactly -pi/4, and then 3pi/4. And I might have shocked you here saying -pi/4, where you have to remember the range of arctangent. Arctangent, the range of it goes from pi/2 to -pi/2. And so I kind of did some conversion here and I added pi to this to get the other value. But we might have also have said, I believe this would be what, 7pi/4? But we're going to use the -pi/4 for this. You'll get the same location, just -pi/4. So, two thetas, two radii, because we have multiple representations of coordinates, right? We knew that from the first lesson. So let's think of how we're going to do this. So let's say we have a positive radius square root of 2. Okay, we think of the angle measure first. So if I use this angle measure, -pi/4, what quadrant are we going to be in? We'd be in quadrant 4. So I would need, since I need to be in quadrant 2, with this angle measure, I would be in quadrant 4, but give me a negative radius and I would go to quadrant 2. So I'm saying all that to say that our negative radius will be placed with our negative pi over 4. And that's not always the case. Don't think negative, that's not always the case. It's just that to get back to quadrant 2, we had to use the negative radius. And then that would say, oh, well, 3 pi over 4, where's that? That's quadrant 2. So yeah, 3 pi over 4, our radius is positive. So think of where your coordinate is, and we get our two representations. Let's try another. So let's say we had here negative 3, comma 0. So just using our conversions, okay? So we get negative 3 squared plus 0 squared equals r squared. All right, that gives us 9 equals r squared, which would say, oh, positive negative 3. Fair enough. And then our theta, our arctangent of y, 0 over negative 3. So the arctangent of 0, because that's what this comes out to be, the arctangent of 0 is at 0 pi and 1 pi. Okay, so that's the thing of our coordinates. So negative 3, 0. That's not in a quadrant, that's actually on an axis, but that would be, we'll say, quadrant 2 / quadrant 3. That's how we're going to say that. Okay, so we need our point to be on the left side of the x-axis. So let's see, let's use, probably should have started with the angle measure. We look at the angle measure first, right guys? So let's say we have 0 pi, meaning there's no turn. So that leaves me on the right side of the axis. I need to be on the left side, so we're going to use our negative radius. That's how it works. And then if I use pi, well, we already know what it's going to be, but at pi, that takes me around to the left side of our unit circle, so that's where we want to be, so we have a positive radius. All right, moving on. So I'm going to give you one to see how you do. So go ahead right now, pause the video, and convert this rectangular coordinate to polar. All right, so did you get this far? The radius should have been rather easy to find, and then arctangent, just known as a unit circle. So with this, let's see, let's say we have negative pi over 6. Negative pi over 6. Might have to fix this little scratch area here. So let's see. So we are in quadrant 4. So negative pi over 6 is in quadrant 4, so I need a positive radius. That was easy enough. Easy fix. Okay, there we go. And then if I have 5 pi over 6, that's in quadrant 2, so using our negative radius will get us to quadrant 4. Bam, done. Let's look at, let's go from polar to rectangular. So these are much quicker because there's not much thought to it, just knowing the conversion. So there's our polar coordinate, r comma theta. So let's go. X equals r cosine of theta. Fair enough. Y equals r sine of theta. Fair enough. So we say, oh, 3 times cosine of 5 pi over 6. Okay, well, cosine of 5 pi over 6, that, Mr. Beal, that's negative square root of 3 over 2. Which would say, oh, this is 3, negative 3, square root of 3 over 2. All right, and then this one. So we get y equals 3 times sine of 5 pi over 6, which is 1/2. So 3 times 1/2 is 3/2, giving us a coordinate of negative 3 square root of 3 over 2, comma 3/2. done. So think of the quadrant we're in. The angle measure takes us to quadrant 2. The radius keeps us in quadrant 2. Let's think here. Oh yes, this rectangular coordinate left this amount, up this amount. We're in quadrant 2. We're good. Last one. Let's say we have, because we're not always going to have an angle measure in radians or even an angle measure we know along the unit circle. So if we had, say, 2 comma negative 100, it says negative 100 degrees, by the way. Same conversions. So that would be 2 times cosine of negative 100, and then 2 times sine of negative 100. So because these do not lie on a unit circle, we will need to use a graphing device to do this for us. So we have, just type in 2 cosine of negative 100, making sure we're in degree in this case, we are, and we get approximately negative 0.3473. Okay, and then we have 2 sine of negative 100. Giving us approximately negative 1.9696. I have my calculator to fix 4, so you might have had more of a decimal there, but should round to the same. And there we go. Negative 0.3473, comma, negative 1.9696. So look at where we're at. So negative 100 degrees, that takes us to quadrant 3. Radius that's positive, we stay in quadrant 3. Look at a coordinate, we match it, we're good. So it's all about knowing how to use the conversions. Good luck using them, good luck with the practice, and I'll see you in the next video where we look at converting equations.